Hello students, this is your physics class. So student, in our last lecture we have done formation of rainbow. So students, today we have discussed advanced sunrise and delay sunset. So what happened to sun? Why look red in color during rising and sunset? So I am going to share a video which represent and illustrate some fact why sunrise advance and why sunset time delay. You have to pay attention and listen information carefully.
Advanced sunrise and delayed sunset. We know that the atmospheric refraction of light causes celestial objects to appear higher than their actual position in the sky. Let us consider the example of the sun. We know that the earth revolves around the sun. As the earth revolves around the sun, the relative position of the sun with respect to the earth changes. In the earth's sky, the sun appears to rise in the morning and set in the evening. So, what does the rising and setting of the sun mean? When we look across the sky, we can notice an apparent line below which we are not able to see the sky. This is the line where the earth and the sky appear to meet and is called the horizon. This line is tangent to the earth's surface at the point of observation. When the position of the sun changes from below the horizon to above the horizon, it rises in the earth's sky. Similarly, when the position of the sun changes from above the horizon to below the horizon, it sets in the earth's sky. Let us consider a position of the sun below the horizon. At this point, the sun has not actually crossed the horizon. Its actual position is below the horizon. If there were no atmosphere, the light from the sun would not reach our eyes and we would not be able to see the sun. However, because of the atmospheric refraction, the sun rays continuously bend as they pass through the atmosphere. The sun appears to be higher than its actual position when viewed near the horizon. Its apparent position is above the horizon. Thus, we can see the sun about 2 minutes before it has actually risen above the horizon. This is called advanced sunrise. Similarly, we can see the sun for about 2 minutes after it has already set below the horizon. This is called delayed sunset. An interesting observation is the amount of shift in the apparent position of celestial objects depending on their position in the sky. Notice that the light coming from an object nearer to the horizon enters the atmosphere more obliquely than that coming from an object higher up in the sky. Therefore, the light from an object lower in the sky bends more and its apparent position shifts higher up, while the light from an object higher in the sky does not bend as much and hence its apparent position does not shift as much as well. Hence, the lower an object is in the sky, greater is the shift in its apparent position. The sun's disk appears flattened at sunrise and sunset because of the same reason. The bottom part of the sun is lower in the sky as compared to the top part of the sun. Therefore, the apparent position of the bottom part of the sun shifts higher up, while that of the upper part does not shift as much, thus making the sun's disk appear flattened. Let us summarize what we have learned. The atmospheric refraction of light causes the sun to appear higher than its actual position in the sky. This causes advanced sunrise and delayed sunset. We can see the sun 2 minutes before the actual sunrise and for 2 minutes after the actual sunset. It also causes the apparent flattening of the sun's disk near the horizon.
So students, in this video we have learned the atmospheric refraction take place. That's why sun appear higher than its actual position, and the sun is sunrise is advanced due to actual sunrising time. So this is also cause of delay sunset. Atmospheric refraction is always delayed sunset. We can see 2 minutes before actual sunrise and 2 minutes after actual sunset. It is due to atmospheric refraction. The atmospheric refraction also cause the apparent flattening of the sun disk near the horizon. So that is the reason. Student, after that topic we are going toward practice question 4.13. So you have open your supplementary book, page number SB 12. So question number 4.13. The time difference between an actual sunset and apparent sunset is about 2 minutes. Explain this statement with the help of a label diagram. So students, so the time difference between actual and sunset and apparent sunset about 2 minutes. This is because atmospheric refraction. And actual sunset occur when sun has crossed the horizon. When it's happen, the sun moves below the horizon. So the actual position of sun is below the horizon. Atmospheric refraction causes the sun to appear higher than its actual position for about 2 minutes. And the apparent position of the sun is visible above the horizon. Therefore, the sun remains visible to us for about 2 minutes after it has moved below the horizon. So question number 14.3, description of a label diagram. In this diagram, the earth and with horizon, the actual position of a observer on the earth, but according to sun and according to atmospheric refraction, the actual position of sun is below the horizon. So that is a position which is below the horizon. But due to refraction of light, due to atmospheric refraction, it absorbs before the time. So that absorb before the time. This delay of sunrise is 2 minutes. And when sun become at horizon, so it is the 2 minutes later than sun. So that is a horizon and that is a observer which observe the sun, and this is the same condition when sun going to sunset. At that position we see sunset after sunset and delayed 2 minutes later. So that is a rare. The main cause of delay and advancement is refractive or atmospheric refraction. So student, if you have any problem related to these topic, you have to discuss with me and text me anytime. You have to practice question on your SB12 and practice NCRT exercise on your NCRT book. So thank you students. Happy learning.